Okay, let's unpack this. We've got a stack of sources today, all centered around a blockchain platform called ZeroBrix. It looks like they're taking a pretty interesting route.
Yeah, definitely. We're looking mainly at their technical guide, which lays out the big picture, the architecture, the philosophy.
Right, and then there are these other docs, more technical, diving into specific smart contracts, API stuff, service escrow, token treasuries.
Exactly. Those are more for the developers, the integrators, people who want to actually build or connect things to ZeroBrix.
So our mission today for this deep dive is to really pull out the key insights. We want to give you, our listener, a solid understanding of how ZeroBrix works, what makes it tick, especially if you're working in Web3, maybe development, finance, marketing, or even research.
It's about finding those aha moments, understanding the core systems, the advanced features, but without getting totally bogged down in the super technical weeds. Kind of a shortcut to getting up to speed.
Exactly. We'll guide you through it, highlight what really matters and why. Ready to jump in?
Let's do it.
Okay, so one of the first things that really jumps out, reading through this, it's their starting point. They began as a centralized blockchain API. That sounds, well, a bit backward for a blockchain, doesn't it?
It does, on the surface, yeah. But the docs are really clear about why. It wasn't an accident, it was a deliberate choice.
Okay, so what was the thinking?
Speed, mostly, and agility. By starting centralized, the ZeroBrix team could, iterate super fast. They could build out concepts, test smart contract ideas really thoroughly, debug things much more easily without wrestling with distributed consensus right from day one.
Ah, okay. So build the core engine, get the features right in a controlled environment first.
Precisely. They got immediate transaction finality, which is actually a big plus for some applications, especially early on. It let them focus on nailing the application layer, the smart contract functionality.
Makes sense. But the key thing is, this wasn't the end goal, right?
No, absolutely not. The documentation stresses this. It's a starting point, explicitly designed to evolve towards proper decentralization. The whole architecture is built with that transition planned.
That's a pragmatic approach. Get something working, refine it, then decentralize.
Yeah.
So what's powering this initial centralized phase? What's the tech stack look like?
Well, the front end and API layer looks like they're using Next.js, which is a popular framework for building web apps based on React.
Okay, familiar territory for many web developers.
Yeah, and they lean heavily on TypeScript. That's a good sign for a complex project, helps catch errors early, makes the code more robust, easier to maintain as it grows. Type safety helps a lot.
Definitely. And the ledger itself.
Yeah.
Where's all the data actually stored? Especially if they're planning to scale and decentralize later.
That's where it's interesting. They chose Cassandra as the database backend.
Cassandra. Wow, okay. That's distributed database, designed for massive scale.
Right. Exactly. Even though they started centralized, using Cassandra from the get-go is a huge signal about their long-term plans. It's built to handle enormous amounts of data spread across many machines, high availability, perfect for a system that eventually needs to run on a decentralized network. It's really the core of their data layer.
So the foundation was built for distribution from day one. That's smart planning. How did they structure the data within Cassandra to handle blockchain needs like immutability and finding transactions quickly?
Right. The design focuses on exactly that, making sure history can't be changed and that you can efficiently pull up, say, a wallet's balance or a smart contract's current state.
So standard blockchain tables.
Pretty much. You've got tables for wallets, tokens, balances, the blocks themselves, pending transactions, the mempool equivalent smart contracts, and even specific data structures for governance and voting.
And being Cassandra, they'd use its specific features for performance, I assume. Partition keys, clustering columns.
Yes, exactly. The technical guide mentions leveraging those Cassandra-specific design patterns. The nitty-gritty of how Cassandra does it isn't crucial for most users, but the result is the system can distribute data efficiently and retrieve it fast, keeping things snappy even as the platform grows.
Got it. Centralized start, but built on a scalable, distributed-ready database. How do people actually talk to this thing? What's the API like?
They went for familiarity. It's a standard RESTful API. Most web developers will find that pretty comfortable to work with.
Makes integration easier.
Definitely. And they simplified it further. There's a single unified endpoint, a P402, for both getting data, GET, and sending commands, PVOS. Just makes life a bit simpler when you're coding against it.
How about security on that endpoint?
Standard stuff. They mention middleware layers for things like cores, which is important for web apps interacting across domains, and critically, ATI key authentication. So only authorized applications or users can actually make calls and trigger actions.
Good. And is the API structured nicely? Easy to work with different parts, like wallets or tokens.
Yeah, it seems very modular. The different features, wallets, tokens, contracts are broken down into separate modules that promotes reusability and keeps things organized. Developers can just focus on the bits they need, which is always a plus. Clear separation of concerns.
All right, solid architectural foundation. Let's move up a layer to the actual digital identities and assets, wallets and tokens. What's special about a ZeroBrix wallet?
The docs frame it as more than just a place to hold tokens. It's your fundamental digital identity within their ecosystem.
How is that identity created? Public-private keys?
Yep, standard cryptography.
Yeah.
You generate your keys, and ZeroBrix derives an address from your public key. But here's a neat part. The address is Ethereum compatible.
Oh, okay. So it looks and feels like a regular Ethereum address.
Exactly. That means potential interoperability with existing Ethereum tools, wallets, explorers. It lowers the barrier to entry if you're already in the Web3 space.
Smart move. And I saw something about a welcome gift.
Yeah, that's a nice touch. When a new wallet is created, it triggers a smart contract that automatically gives it a small starting balance of tokens.
Oh, cool. So you can actually do something right away.
Exactly. You don't hit that initial wall of, okay, I have a wallet, and now how do I get tokens to even try anything? It enables immediate participation, lets you interact with features straight away.
That's clever onboarding. So you have this identity. How do you prove it's yours when you want to send tokens or interact with a contract?
Through cryptographic signatures, the standard secure way. You use your private key to sign a message related to the action you want to take crucially, without ever revealing the private key itself.
And the system verifies that signature.
Right. Using your public key, which is linked to your wallet address, the system checks if the signature is valid. If it matches, it proves you authorized the action.
And this signature method is used everywhere.
Seems like it. It's a unified security model across the board, simple transfers, complex smart contract calls, even approving those charge requests we'll get to later. Uses that same Ethereum-compatible signature verification. Consistency is good for security. And they highlight how this integrates with smart contracts for more advanced uses, like potentially using your wallet signature for logging into websites or apps that build on ZeroBrix, passwordless authentication.
Okay, yeah, that really elevates the wallet beyond just being a crypto holder. How does it manage the different types of assets you might hold? Fungible, non-fungible.
It's built to handle both meticulously, tracks balances for your fungible tokens, the interchangeable ones like cryptocurrencies, and your non-fungible tokens, NFTs, where each one is unique.
And keeping those balances accurate is key.
Absolutely. The docs mention balance updates are atomic operations. That means a transaction that changes balances either completes fully, updating everything correctly, or it fails entirely. No partial updates, no inconsistencies, even if lots of things are happening at once.
Can smart contracts look at these balances?
Yes, that's fundamental. Contracts need to be able to check balances. Maybe you need a certain amount of tokens to vote or to use a specific feature. Or maybe the contract logic involves moving tokens based on balances. It's tightly integrated.
Okay, makes sense. Let's talk about creating those assets, the tokens themselves. Sounds like a sophisticated system.
It does. It's more than just create a coin. When you define a new token on ZeroBrix, you specify its core nature, fungible or non-fungible. You set the initial supply. And importantly, you can embed rich metadata.
Metadata, like descriptions, links.
Yeah, defining what the token represents, its purpose, rules, maybe linking to images or documents. It gives the token context and utility, and every token gets a unique ID.
And again, strong ties to smart contracts.
Very strong. Token creation, supply changes, rules, a lot of that can be governed by smart contracts. You can have tokens with dynamic supplies that mint or burn based on contract logic, or tokens that interact with other platform features in complex ways.
Let's break down the fungible ones first, like regular crypto, but maybe with enhancements.
Pretty much. The key features highlighted are dynamic supply contracts, can mint more or burn existing ones, and high precision tracking, which is vital for any serious financial application.
And there was that internal economy idea.
Right. The platform allows setting and managing exchange rates between different fungible tokens, usually relative to a main reference token. This creates a sort of built-in exchange mechanism, allowing value to flow between different token types within the ZeroBrix ecosystem itself.
And this system is what enables the specific tokens we heard about, like ZeroCoin, Service Token.
Exactly. Those are built using this fungible token framework. ZeroCoin, Zero, is positioned as the platform's main currency. And this is crucial for anyone listening who might want to work with ZeroCat.
The company behind ZeroBrix.
Right. The sources are explicit. If you want to use ZeroCat services, things like their blockchain consultancy, getting custom software developed, using their AI integration services, you need to pay using ZeroCoin, ZeroRow.
Okay, that's a very direct utility. It ties the main platform currency directly to the value offered by the core team. Creates a real reason to acquire and hold Zero.
Precisely. It's not just speculative. It's required for access to their expertise and products. Then you have the other tokens, also fungible. Service token is mentioned as the currency for their decentralized task marketplace, powered by that service escrow contract.
We'll definitely dig into that one later.
And System Coin is flagged for things like mining rewards in the future, or maybe payments for using automated ZeroCat resources like servers or bots. Each token has a clear, defined role.
Got it. How about the non-fungible tokens, NFTs? Standard unique digital items.
Yep. Each NFT has a distinct identity, can't be divided. They support rich metadata, so you can use them for digital art, collectibles, maybe even representing real-world assets or deeds down the line.
And ownership tracking is solid.
Rigorous tracking, the docs say. Clear ownership, full history provenance, all recorded immutably.
Okay, so we can create and own tokens. How about moving them or changing the supply? Minting, burning, transfers.
Those are the core operations. Minting creates new tokens, increases the supply, assigns them to wallets. But importantly, the sources note that minting key tokens like Zero or Service Token isn't just open season. It's controlled by specific smart contracts.
Like the treasury contract we'll discuss.
Exactly. Burning is the opposite. Permanently destroying tokens, removing them from circulation, can be used for deflationary mechanics, again, typically managed by smart contracts, and needs careful balance updates.
And transfers.
Moving tokens between wallets. Simple transfers are straightforward, check balance, check authorization, move funds. But transfers can also be complex, orchestrated by smart contracts for things like swaps or payments that only happen when certain conditions are met.
Right. We've got identities, assets. Now, how does value actually move? The transaction layer.
This is where it all comes together. A ZeroBrix transaction isn't just sender, receiver, amount. They have this transaction details field.
The rich metadata field.
Yeah, it's really powerful. It lets a transaction carry more complex instructions. Instead of just send X tokens, it can say execute function Y on smart contract Z with these parameters. Opens up a lot of possibilities beyond simple payments.
What checks happen when I send a transaction?
Few key steps. First, signature verification proving you authorized it, using that crypto method we talked about. Then, balance checks make sure you have the funds. If it involves a smart contract, there might be contract-specific validation too.
And if it passes?
It gets a unique ID, a timestamp, and it's ready to be added to the ledger. Becomes part of that immutable history. Typically, before it gets finalized, it lands in what's essentially a mempool, a holding area for pending transactions. This gives you quick feedback that it's been received. Then the system orders them and picks them for the next block.
You mentioned charge requests earlier. How do they fit in?
They flip the script a bit. Instead of you pushing a payment, someone else, maybe a merchant, requests payment from you.
So like an invoice on the blockchain.
Kind of, yeah. They send a request for a specific amount. You then have to actively approve that request with your wallet signature. Only then does the actual token transfer happen. The system tracks the status pending, approved, rejected. It's a useful pattern for certain business flows.
Interesting. Okay. Transactions are submitted, validated, waiting in the mempool. How do they become permanent? The mining step, even though it's centralized for now.
Right. Mining is the process that takes those pending transactions and seals them into immutable blocks on the ledger, finalizes them.
The sources mention proof of work, but call it symbolic currently.
Exactly. Because it's centralized right now, there's no need for PoW to achieve consensus among distributed miners. But crucially, the structure is fully implemented.
So they have the mechanism ready.
Yeah. A miner, currently part of the centralized system, gathers transactions, technically solves a placeholder puzzle, creates a block with those transactions, includes a nonce, and crucially, hashes the previous block to form the chain. It mimics the PoW process completely.
Building for the future then. How are transactions processed within these blocks?
It's done atomically. Standard transfers just update wallet balances. But if a transaction interacts with a smart contract, the block processing triggers that contract's logic. This might involve burning tokens, updating the contract's internal state, recording those immutability hashes we'll get to, or even spawning new transactions.
And if something goes wrong during execution?
This system is designed to revert failed transactions within the block. So if a contract call fails midway, the funds involved should be returned, maintaining consistency.
Is there a reward for this mining, even symbolically?
The infrastructure is there. The docs mention special transactions from a system address designed to pay mining rewards, but reflecting the current centralized state, those rewards are set to 0 for now. Again, it's about having the mechanism built and ready for when actual decentralized mining kicks in.
They really seem to have built the entire scaffolding, even for the future decentralized parts.
That's definitely the impression. Handling things like treasury burns or contract executions that create follow-on transactions all atomically within a block is key for ledger integrity, and they seem to have addressed that.
Okay, foundation, identity, assets, transactions, recording. Now for the really programmable stuff. Smart contracts. The sources call the architecture a modular marvel. High praise.
It sounds like they put a lot of engineering effort here. The focus is definitely on modularity, extensibility, and separating the how-to-run logic from the what-to-run logic.
How does that work in practice, this executor pattern?
Think of the executor as the main engine. It knows the general process for executing any smart contract, but it doesn't contain the specific code for, say, a token swap versus an escrow agreement.
So it delegates.
Exactly. It interacts with pluggable implementations, separate modules of code for each specific contract type, token exchange, service escrow, etc. This makes the system really flexible. Adding a completely new type of smart contract becomes much easier because you just need to build a new pluggable module, not rewrite the core engine. It's layered. You have the main smart contract executor, then the specific contract implementations supported by common utilities, caching for performance, logging for debugging, and so on.
So adding new contract types is straightforward. The plugin system.
Yeah, that seems key to their extensibility claim. Developers can create new contract types by building them as plugins that follow a specific interface, i.e. smart contract. There's a plugin manager that handles registering these new types, validating them, managing their lifecycle. They even mention potential for hot reloading, which is great for development. It really positions ZeroBrix as a platform you can build diverse applications on.
Sounds powerful. What's the typical life cycle of one of these contracts?
Starts with creation. An owner defines the contract type, sets its initial configuration. The system generates a unique ID and address for it, stores the initial state. And critically, this is where the immutability system kicks in. It records a cryptographic hash of this initial setup on the blockchain.
We'll need to circle back to that immutability system. What happens after creation?
During its active life, the owner can potentially update the configuration with authorization and tracked by immutability. Users might need to subscribe to interact with it, and execution happens when a specific transaction targets the contract. All actions are logged for auditing.
Can they be deleted?
Yes, deletion is possible. But even if a contract is deleted, the immutability system ensures its entire history, all its past states and actions, remains permanently recorded and verifiable on the blockchain.
You mentioned subscriptions. Why require users to subscribe to contracts?
The sources suggest it's a design choice for many contract types. It achieves a few things. Establishes clear user intent. Yes, I want to interact with this. Helps manage lists of authorized participants for certain actions, and could enable future features like sending notifications or updates only to subscribers.
But not all contracts require it.
Right. Core functions like using the token treasury for buying, selling tokens, or the authentication contract for logins probably wouldn't require individual subscriptions to be practical for widespread use. They mentioned exceptions exist.
Okay, so let's say I'm subscribed, if needed, and I send a transaction to trigger a contract. Walk me through the execution flow.
Sure. It starts when a special transaction targeting that contract ID arrives. The system first loads the contract's data, using caching to speed things up. Then it validates checks if you, the sender, are authorized to perform this specific action on this contract.
Builds context.
Yep. It builds an execution context, which bundles everything needed. The details from your transaction, any parameters you included, the contract's current configuration, your wallet identity.
And then passes it off.
Exactly. This whole context package is passed to the correct plugin, the specific code for that contract type. That plugin runs its logic based on the context.
What happens as a result?
The plugin determines the outcome. It might update the contract state, like changing an escrow status. It might generate new transactions that need processing, like sending tokens out. Or it might require the original transaction to do something specific, like burning input tokens. The result, success or failure, is recorded.
A very defined process. The sources list quite a few specific contract types already built. Let's look at some examples. Token exchange.
Right. This one's for automated swaps. You configure it with two token types, input token id, output token id, and a fixed exchange rate. You send the input token to the contract's address.
And it automatically sends the output token back.
Exactly. Calculates the amount based on the rate, takes a small fee probably, and sends the output token back to you. It's like a basic decentralized exchange DEX function built right in, tying into that internal economy idea.
How about token distribution?
This one's for splitting funds. You configure it with a list of recipients, recipient address, and the percentage each should get. You send tokens to the contract.
And it automatically divides and sends them out.
Precisely. Great for things like profit-sharing agreements, royalty distributions, maybe even complex airdrops. Takes the manual work and potential errors out of splitting funds.
Conditional transfer sounds self-explanatory.
Yeah, it lets you set up transfers that only happen if certain conditions are met. You define the reward amount, recipient address, token ID, and the rules.
Like the welcome gift example?
Perfect example. The condition could be, is this a new wallet address? If yes, trigger the transfer. Or it could be time-based or based on some other on-chain event. Very flexible for rewards, scheduled payments, etc.
Governance contracts, these must be key for the decentralization roadmap.
Absolutely fundamental. They manage the whole process for making decisions collectively. Someone holding enough of a specific token ID used for voting power, requires meeting proposal threshold, can create a proposal.
Then voting happens.
Yes, during a defined voting period. The contract checks for quorum, minimum participation. There are different voting system options like one token, one vote, or maybe more complex ones like quadratic voting. You can usually delegate your voting power too.
And if a proposal passes,
There's typically an execution delay, a waiting period, before the proposed action is automatically triggered on-chain by the contract. It's the mechanism for community-driven platform changes.
voting contracts are similar but different.
Right. They're for specific one-off votes or polls, not ongoing governance. Configure them with a voting token, start time, end time, the options people can vote on, and a voting system. Uses the same underlying token-based voting power and delegation system. Good for getting community sentiment on specific issues.
Authentication contract, that's the website login mechanism.
Exactly. It enables that passwordless login using your ZeroBrix wallet. The contract stores the website's wallet address, website wallet address, and its domain name.
How does the login flow work?
It's pretty neat. The website asks the contract for a unique one-time nonce. It shows this nonce to you, maybe as a QR code. You use your wallet to sign a transaction containing that nonce. Your signed message goes back to the website's server.
And the server checks it with the contract?
Yep. The server calls the contract's API saying, hey, did this user sign this nonce correctly? The contract verifies the signature against your public key and the nonce it issued. If it matches, the website knows it's really you and logs you in. Secure, no password needed.
Very cool application. Okay, let's really dig into the two big ones detailed in the sources: service escrow and token treasury. Service escrow sounds like a game changer for freelance work.
It's definitely positioned that way. It aims to manage the entire life cycle of a service agreement on the blockchain. Super useful for freelancers, clients, marketplaces.
How does it work at a high level?
The client initiates it. They create a ticket with details like an ID, the payment amount, the specific token to be used, service token ID, and this is key, and their address, creator address. The crucial part is the client has to deposit that payment amount into the smart contract's escrow upfront.
Funds locked in until the job's done. Are there fees?
Yes, a dual structure is mentioned. There's a fixed platform fee, stated as 5%, and a configurable escrow tax percent, ranging to 15%. These fees are calculated on the escrow amount, but importantly, they're only deducted if the job is successfully completed and the provider gets paid.
Makes sense. What are the different stages or statuses a ticket goes through?
It follows a clear path. Starts as awaiting funds until the client deposits the payment. Then it's funded, meaning a provider can claim it. When a provider accepts, acceptor address is recorded, it becomes accepted work starts.
What happens when the provider finishes?
They mark it as provider completed. This kicks off a review period for the client. Ideally, the client reviews the work and marks it completed. That's the trigger for the contract to release the escrowed funds to the provider, minus those fees.
What if the client just ghosts them, doesn't respond after the work is submitted?
That's where the auto-release feature comes in. It's vital protection for the provider. If the client doesn't mark the ticket completed within a set time window, auto-release hours,
Yeah.
after the provider marked it done, the default is 72 hours. Max seems to be 168 hours. The contract automatically releases the funds anyway.
So the provider gets paid even if the client is unresponsive.
Exactly. It prevents clients from holding funds hostage indefinitely. The docs even suggest client-side apps could redundantly trigger this if needed.
Can you break down big projects?
Yes, it supports milestones. You can structure a large project into smaller phases, each with its own payment amount escrowed and released upon completion. The same rules, including auto-release, apply to each milestone.
What about disputes or cancellations?
Mechanisms exist. There are rules about when you can cancel. And penalties for acting in bad faith, like if a client cancels after the provider has already marked the work complete, the provider might still get the full payment plus the tax amount. The blockchain record provides evidence if things escalate.
This sounds exactly like the engine for that decentralized task marketplace mentioned earlier.
It is. The sources explicitly linked this service escrow contract to that marketplace. And crucially, payments within that marketplace use the service token. That service token field in the contract setup is where you specify it. So if you're using the ZeroBrix task marketplace, you're interacting with this contract and you're using service token for payments.
Clear link between the token and a core platform utility. Okay, the other big one, token treasury. What's its main job?
This one is all about managing token supply, minting, and burning, specifically to connect ZeroBrix tokens with the traditional financial world. Think fiat on-ramps and off-ramps.
So this is how you buy Zero with dollars or sell Zero for dollars.
Precisely. It provides a controlled way for an authorized entity, like an exchange, to mint new tokens when a user makes a fiat purchase, and to burn tokens when a user wants to sell them back for fiat. You typically set up one treasury contract per token you want to manage this way, linked to an admin wallet address.
Let's walk through buying tokens with fiat, say using a credit card via Stripe.
Okay. The user pays with their card on, say, an exchange website. The exchange's backend gets confirmation from Stripe that the payment went through. Then, that backend, which has the admin rights for the treasury contract, makes an API call to the treasury contract on ZeroBrix.
Telling it to mint tokens.
Exactly. It sends a special transaction instructing the treasury contract to mint the purchased amount of tokens directly into the user's ZeroBrix wallet recipient address. The contract ensures only the authorized admin can trigger this.
And selling tokens back for fiat, like getting a wire transfer.
It's the reverse flow. The user initiates the sell on the exchange platform. Then, the user sends the amount of tokens they're selling to the treasury contract's address on ZeroBrix. This transaction needs specific transaction details, tagging it as an action burn for that contract.
The exchange backend watches for this.
Yes. The exchange's backend monitors the ZeroBrix blockchain. When it sees that the user's burn transaction has been successfully confirmed, mined, it knows the tokens are destroyed. Only then does it initiate the fiat payout to the user, like sending the wire transfer.
So confirming the blockchain action before moving the fiat is critical.
Absolutely vital for security and preventing loss. You need to monitor the transaction status. If the mint fails, you refund the fiat. If the burn fails, you notify the user before sending fiat. The sources also stress standard security practices. Don't store user keys, secure your API keys, use good accounting, watch for fraud.
This sounds exactly like the system needed for the ZeroBrix exchange platform.
It is. The docs connect the dots explicitly. They state that exchange.zerocat.1, the official ZeroBrix exchange, uses this token treasury smart contract to handle its main fiat flows.
So buying Zero with USD via Stripe uses this minting flow.
Correct. Your Stripe payment confirmation triggers their backend to call the treasury contract to mint Zero to your wallet.
And selling Zero for USD via wire transfer uses the burning flow.
Yes. You send Zero to the treasury address with the right details. Their backend confirms the burn on-chain. Then they process your wire payout.
That makes a treasury contract very concrete. It's the engine powering their main fiat gateway. And you mentioned they plan to add more methods.
Yeah, the sources say more fiat and crypto on-off ramps are planned for the exchange this year, likely leveraging this treasury mechanism or similar ones, possibly with different KYC requirements depending on the method.
Okay, we've seen these powerful contracts. But how do we trust them? How do I know the service escrow contract I'm using today is the same one with the same rules as yesterday? Hasn't been sneakily changed.
That's the million-dollar question in smart contracts, right? ZeroBrix tackles this with what they call the judiciary system. It's their approach to ensuring verifiable contract immutability.
Judiciary system. Sounds official. How does it work?
There's a special system account, the Judiciary Manager. Its job is to create cryptographic proofs of a contract state at specific points in time. It seems like this is a ZeroCat managed function for platform integrity. The process is, it takes all the essential parts of a contract, its ID, owner, type, the actual configuration data, normalized so it's consistent, any conditions, timestamps, version info, and calculates a SHA-256 hash of all that. It has to be deterministic, same input always gives the same hash.
Like a unique fingerprint for the contract's exact state.
Exactly. But the crucial part is where that fingerprint is stored. It's not just logged somewhere off-chain. The Judiciary Manager account initiates a special transaction to record that hash directly onto the ZeroBrix blockchain itself.
Ah, so the proof becomes immutable, along with the rest of the ledger.
Precisely. Once that hash is in a confirmed block, it can't be altered.
What if a contract legitimately needs an update?
That's where the version chaining comes in. When a contract is updated, the Judiciary Manager calculates a new hash for the new state. But this new hash calculation also includes the hash of the previous version.
Creating a linked history.
Yes, a cryptographic chain linking every version of the contract back to its origin. If anyone tried to tamper with a past version's data or its recorded hash, the chain would break. It makes any unauthorized changes instantly detectable, allows evolution while maintaining full auditability.
So if I want to verify a contract, I can recalculate its current hash myself.
Right, using the same deterministic method.
And compare it to the latest hash recorded on the blockchain by the Judiciary Manager.
Exactly. If they match, and you trust the blockchain's integrity, you have strong cryptographic proof that the contract is configured exactly as represented by that on-chain hash. It's a core trust layer.
That's a clever system. Adds real confidence.
Yeah.
Okay, broadening out again, how does all this fit together into a token economy, market dynamics?
The exchange system, whether through contracts like Token Exchange or platforms like the ZeroBrix exchange, provides the venue. The ability to set exchange rates between tokens, especially against a reference token like Zero, creates that hub-and-spoke model for value transfer.
Who sets those rates initially?
The docs indicate governance can play a role now, but the system seems designed potentially for more market-driven rates later, maybe through AMMs, automated market makers, built as smart contracts, or even order books. They do track historical rate data, which is useful.
And when an exchange happens?
The calculation uses the current rate, applies a configurable tax, mentioned as 2% currently, and it's all atomic completes fully or not at all. Transparency is key too, showing quotes with fees up front.
And tracking market health.
Yeah, they mentioned tracking volume and liquidity metrics. These give users insights into how active and stable the market for a particular token is within the ecosystem. Initially, liquidity might be informed by governance or external feeds.
And finally, those governance and voting contracts, how do they tie into trust and the economy?
They're critical for the long-term health and decentralization. Governance contracts provide the formal mechanism for the community, token holders, to make binding decisions about the platform's rules, economic parameters, fees, maybe even technical upgrades.
Decisions enacted on-chain.
Yes. Voting contracts allow for specific polls or decisions. Together, they provide the framework for decentralized authority, building trust by giving participants a real say in the platform's evolution and aligning incentives within the economy.
Wow. Okay. That was a really deep dive. We covered a lot of ground there.
We really did. From that initial centralized but scalable architecture using Cassandra.
Right. Through the wallets is digital identities, the Ethereum compatibility, the sophisticated token system.
The transaction layer, the symbolic but ready mining, and then that whole powerful modular smart contract engine.
Yeah, especially looking at practical examples like the service escrow for tasks.
Using the service token.
And the token treasury, enabling those crucial fiat on and off ramps.
Which powers the ZeroBrix exchange using Zero.
Plus the judiciary system for trust through immutability proofs, and the foundations for the economy and future governance. It paints a pretty comprehensive picture.
Definitely. The takeaway seems to be a platform aiming for real-world utility, built pragmatically with a clear path towards decentralization. The tech choices, the modularity, it feels like a solid base for building actual Web3 applications and economies.
And for you listening, depending on your interest, developer, finance pro, marketer, researcher, there are concrete things here. Developers get APIs and extensible contracts.
Businesses could leverage service escrow for marketplaces, or treasury for integrating tokens with fiat payments.
Researchers get transparent data, a unique trust system to study, and evolving governance.
And it's important to circle back to that direct link. engaging with ZeroCat's own services. As the sources clearly state, if you want their expertise consultancy, custom dev, AI stuff payment is required in ZeroCoin.
So that creates immediate, non-speculative demand for Zero. And the place to get it, or sell it, is the ZeroBrix exchange at exchange.zerocat.one.
Correct. Using that treasury contract for the USD stripe to zero minting and zero burning for USD wire payouts, with more methods apparently on the way.
And for everything else, ZeroCat, their services, info, help. The main hub is www.zerocat.one. They've got an AI chat there too, and a blog for updates and deeper topic explorations. Worth checking out if this has piqued your interest.
Seems like they're building a whole interconnected ecosystem, focused on getting things done and moving methodically towards decentralization.
So here's a final thought to chew on as we wrap up. ZeroBrix took this path. Build complex, useful features like service escrow first, on a controlled but scalable base, while engineering for future decentralization. That's different from many projects that prioritize decentralization above all else from day one, sometimes delaying advanced features.
It's a trade-off, definitely.
Right. So what does this pragmatic, phased approach suggest about how blockchain might actually achieve mainstream adoption? Could this strategy build the killer apps with initial control, then progressively decentralize be a more effective bridge for bringing complex real-world interactions onto the blockchain? Makes you wonder about the different pathways these technologies